Okay, everyone, thanks for coming, and hello, my name is Matt. Today, going to talk about the .NET Standard, which is something which is fairly new, fairly recent. It's come out of the work with the .NET Core. Has anybody come across .NET Standard yet? Have you just kind of heard about it, need to know a bit more? Okay, good stuff. We'll go straight into it. What is the .NET Standard? It's a specification which defines a version set of APIs that are guaranteed to be implemented by a .NET platform. So it'll tell you what APIs are available, what you can target, and what you can run. If you have a library that targets the standard, it runs on all supporting platforms. And that's basically it. So it's a nice, easy thing in and of itself. It's a nice, easy concept. That's pretty much all there is to it, except there's always a bit more which you can go into and have a look at. So, we're going to have a look really sort of, what APIs are included, how does versioning work, what about the compatibility with existing frameworks, existing platforms. How does it relate to .NET Core and portable class libraries? And then also have a look at how does it work. I always like to go like a level down to see what something is actually doing there, and it gets a better understanding then of how something works and what it's doing. And then also we're going to have a look at .NET Standard 2.0, the latest version that they're working on right now, which has big changes and which is probably the reason you've heard about .NET Standard. This is all about adding all the extra APIs back into the .NET Core, which got removed. So we're going to kind of back up a little bit first, and we'll start with what problem we're trying to solve here. What is it that the .NET Standard is trying to fix? And basically, if we look at .NET, we kind of tend to think .NET Framework, maybe .NET Core as well, but there's much more to the .NET than that. Of course, you've got .NET Framework, .NET Core, you've got lots of other frameworks as well. .NET Compact Framework, .NET Micro Framework even. You've got Silverlight, Windows Phone, you've got Mono with Xamarin and Unity as well, and or even Xbox. So .NET is more than just .NET Framework, more than just .NET Core. And all of these implementations are different as well. So some of them started as forks. So you had .NET Framework, .NET Compact Framework was forked off for that, all for different reasons as well. You get a smaller footprint, running in more of a constrained space. .NET Micro Framework, again, smaller footprint, running in a constrained space. Silverlight, smaller footprint, running in a constrained space, but also cross-platform. So that's nice. Windows Store, Windows Phone, the same things here. Mono is different in that it's a completely different implementation, completely separate to .NET Framework. It's not a fork at all. But what it all means really is that they are different implementations. The different implementations over time, that have evolved over time as well. And so there are differences. There's incompatibilities between the frameworks. So the reason that they were forked in the first place, to get a smaller footprint, to get a smaller set of libraries, means that different APIs have been cut out, and different APIs have been included. And so there's differences between the two. So it all brings down to one big question. How do you share libraries and code across the different implementations? And that's what the .NET Standard is going to do. It defines the APIs that are available on all of those platforms. If you target the spec, you can run on the supporting platforms. But isn't that just portable class libraries? Great question. Glad you asked it. Thank you. The answer is, of course, yes, but also no. So portable class libraries do solve the same problem. The whole point of them is to target multiple platforms, to run on multiple platforms, and they do it in a slightly different way. They target profiles rather than frameworks. So instead of saying, I'm going to run on .NET Framework 3.5, they're going to run on profiles, profile 7, 21, 486. And these profiles are API subsets. They are the common APIs that are available on all of those versions of the frameworks that you are targeting, the different frameworks that you're targeting. Frequently, this is seen as a lowest common denominator, but it's really kind of more accurate to say that it's an intersection of the APIs. It's not really just the least things that are there, but it's everything that you can use rather than just the least things. And so it kind of solves the same problem. But portable class libraries have their own problems. So, first of all, they are really a little bit weird and arcane. The whole thing is based on profile numbers, and these profile numbers are effectively random. You can't assign any particular value to these numbers. They're just the next profile along. You can't reason about them. You can't say when there's a new version of something, is profile 236 the next version of profile 48 or whatever. There's no relation, there's no version, and it's all a bit weird. The tooling can hide a lot of this for you. So Visual Studio's got dialog boxes with checkboxes and drop-downs, which tells you what frameworks you're targeting, what versions you're targeting, and it can work it all out for you. But other than that, it's all just a bit odd and tricky to work with. The big problem, however, is that they're not scalable. When you add in a new API, when you add in a new version of a framework, or even when you want to add in a new framework itself, like .NET Core, then you have to have a new profile. And if you've got a new profile, it's a new profile number, you have to recompile, retarget, repackage, redeploy stuff. And so that doesn't help, especially with something like .NET Core. A new platform comes along, you want to use existing code and reshare existing libraries, but you have to rebuild everything to do so. And so that doesn't work with .NET Core. So .NET Standard kind of flips the whole model. Instead of portable class libraries, you can kind of consider them a pull model, really. They find the common ground between them all, gather it all together, and say, here's a profile you can target. .NET Standard is more of a push. It defines the specification. It defines the APIs that are available. And it says, these APIs will be available. You target this specification, and the platform will implement it. And so again, libraries target the standard, they run on supporting platforms, but the key thing is they run on new platforms as well. If the new platform comes along, as long as it supports the standard, as long as it implements the standards, then the APIs and the libraries will just work, hopefully. So, .NET Standard is a specification. What does that mean? You know, we kind of had a look at the why now, let's have a look at the what. So firstly, it's not a Word document. It's not a really dry, sort of hard specification like that with a list of APIs that have to be implemented. It's a binary specification. It's a set of reference assemblies which you compile against. You build against that, and those are the APIs that are available to you. This is then distributed in a NuGet package with its own versions. This is the netstandard.library package. And then within the package, there are new versioned target framework monikers. So you know the lib folder you get with net46, net25, Xamarin, Mono, and so on. We've got a new one now, which is net standard, and that's versioned with 1.0, 1. Whatever, all the way up to 2.0, which is the new one. So, target frameworks. Just as a reminder, so the target framework monikers, these folders in the lib folders. The key thing with target framework monikers is that you depend on a NuGet package, but it's not the version of the package that you're interested in. You're interested in the target framework moniker itself. So you can have different versions within the package based on the target framework that you're targeting. So you can pull in a particular version of a package, and it's whatever framework that your project is targeting that decides what assembly gets referenced. It's also useful to think of target frameworks as a platform, and this is a good way of sort of getting to grips with the idea of the .NET Standard itself. So .NET Framework, .NET Core, they're concrete platforms. Your apps run on those. You know those are implementations, they're built, they're concrete, that's what you run on. The .NET Standard, you can consider that to be an abstract platform. Your code can't run on it, there isn't actual implementation for it, but it's the definition of a platform. Your concrete platforms can then implement it. It's like an interface, as it were. So again, libraries target, they can target the .NET Standard as an abstract platform, and that means they get to run on all of these platforms. But they can also, of course, target a concrete platform. And this way they can get platform-specific APIs. So if you're running on .NET Core, you can have a library which targets directly .NET Core, and it can make use of APIs that are available only in .NET Core. And then your app never targets the .NET Standard. It always targets a concrete platform, because it's always going to run on a concrete platform. Here's a nice analogy of way of thinking about it as well. If you think about HTML, you've got HTML3, 4, whatever, and you write HTML which fits to that standard, because you're all good developers. But then when you run that on Chrome, you're not running HTML3, you're not running HTML4, you're just running HTML in Chrome. And it's exactly the same with the .NET Standard. You target a particular version of it, and you just run it on a platform. Don't take this analogy too far, because it's HTML, and it's scary, but that's a nice way of kind of looking at it and thinking about it. Does anybody have any questions right now, by the way? If you have any questions, please feel free and jump in and dive. Good. OK, versioning then. So I've mentioned the NuGet package is versioned, and the target framework monikers themselves are versioned. And so how does versioning work with the .NET Standard? The first thing is that the .NET Standard is an additive versioning system. So you only ever add APIs into the .NET Standard. It defines a set of APIs you're going to use. and they will only ever be added to them. Nothing gets removed. So the standard is kind of immutable, and we get to add in assemblies, we can add in types, we can add in type members, but nothing gets removed out of it. This has the nice property of meaning that all versions are supersets of previous versions. So if you have a platform that implements 1.6 of the standard, you also know that it's got all the APIs from 1.5, all the APIs from 1.4, and so on and so forth. That also means that a newer platform, if it targets a newer version of the standard, it can consume anything that targets an earlier version. So you've got that sort of backwards compatibility thing built in from that, because everything's a superset. Another good question, glad you asked. How, if it's such a brand new thing that we don't really know so much about it, how have we got so many versions? Can't use the .NET standard. You have to have another assembly to go with it. Well, this is probably okay because they're all out of support anyway. So 4.5 and 4.5.1 are even out of support. They're out of support this time last year. And so you should be on 4.5.2 or 4.6 and so on. What else can we say about this? If you have a look at the platforms down the bottom, so Windows 8.1, that's the last one that supports the standard 1.2. It doesn't support anything else. So if you have a 2.0 platform, a library, you won't be able to consume it on Windows 8.1 or Windows Phone Silverlight. So anybody really upset? Just checking. What else have we got? So Windows 10 apps. Windows 10 supports 1.4, and before it, the 2.0 will be supported in the next version of the Windows 10 platform there. So I realize this is a big kind of complicated thing there. So does anyone have any questions? Yes.
Since you can only add new things to a platform, does it mean that you can't really clean up things? So is there a risk of the platform getting bloated because of that?
Yeah, so the question there was if you can only add APIs, is there a risk of the platform getting bloated if you can't remove it, if you can't clean up your code? And the answer is yes, absolutely. So I'll talk more about that when I get to the .NET Standard 2.0 stuff. I'll leave it at that. But yes, there definitely is a risk there. And you have to manage how you add things in, basically. And so there's a process for that. Anybody else have any questions about the versioning here that we've got? Okie dokie. Right, so given all that, the question becomes what version of the .NET Standard should I use? And it becomes a trade-off. Because the higher version that you target, you'll have more APIs available to you because it's more supersets, but the less platforms you'll have to run it on. So if we have a look at, where are we, if we want to target 1.3 or above, we have to be running on .NET Framework 4.6. If we are targeting 2.0 with the extended API set that's available, we'll only be able to run on 4.6.1, and that can narrow down your targets of what you want to implement on. So yeah, a higher version, you'll get more APIs but fewer platforms. A lower version will give you more of a reach, but it'll have then less APIs there to go for. So it's a trade-off, and the idea is you just target the lowest version you can, because then if you can run on a lower version, you'll get a broader reach. So what APIs are included? This is a useful one. So we have a link here. Let's hope my Wi-Fi is working. Yep, very good. So it's all on GitHub. The standard is on GitHub, and there's some very nice docs and very useful documentation here with another sort of another run through of the version matrix that's going on there, and also some advice, also some mapping between some of the portable class library profiles. But the thing I want to show you really is along the top here, these versions of the .NET platform are links, and it'll take you to useful information about that particular version. So this will tell you what's in the .NET Standard 1.2. It tells you what platforms are supported and what versions of those frameworks are supported for that for that standard, and also a kind of like a high-level overview of what's new, what APIs are in that particular, by namespace and so on. Two useful links we've got here, though, are APIs and then a diff with the previous version. The APIs is all of the APIs that are in the standard, which has killed my Safari, beach ball. So that's a big list. And then a bit easier to manage is the diff. And this shows you then what APIs have been added. And so it's a reasonably small set in this example. We can click on Overview to go back to the page. No, to go back to that page. And so we can see, if we go up to 1.6, again, there's a set of APIs that have been added. And if we go and look at 2.0, which is the new extended API set, we'll see that there's now actually, they're adding a ton of new APIs. So there's a whole load of things. And I'm not even going to try and load the diff for that one. Now, where do I put that? OK, so that's a really useful site there to see what APIs are available, what you can target, and if you want to just have a look at it. A slightly better way of doing it, a slightly more automated way of doing it, is by using the portability analyzer, which Microsoft have produced. It's a really useful tool. There's a command line version of it, API port, and then there's a plug-in to Visual Studio itself. And it'll give you a nice sort of report of what APIs you're using and whether they're available on a particular target framework. It's not just for the .NET Standard either. So you can tell it to analyze your code and say, does this work on .NET Standard 1.0? Does it work on .NET Standard 1.6? Or does it work on .NET Framework 4.5? And it'll run through and it'll tell you what's there. And it will say whether these APIs are available or not. It can even give you recommended changes. So if it's saying that something needs to move, then you can reuse this, which is a useful way of working with it. So this is now answering the question of how do we work with something which is purely additive, and how does that work? This kind of works post 2.0. So they know what they're doing with 2.0. That's kind of like a line in the sand. This is to fix the issues with APIs that were removed from .NET Core and to bring .NET Core back up to parity and make it easier to work with porting between .NET Core and .NET Framework. So there's a known set of work for 2.0. But what happens after? And this is the process they got set up. There's a review board, and that consists of the .NET team, Xamarin, and Unity. The project's open source, so I'm sure if you have comments and things and raising issues, it would be addressed and absolutely fine. But it makes sense for these three to be the board members because they are the people who implement platforms. So they have the most they're the most impacted by this. The idea really is that not everything will be added. So they want to try and keep the standard small because it does need to be implemented everywhere, and if it's going to be implemented on small devices, then a smaller API is good. So they're going to try and keep things out of the standard, basically. We want to work with things like out-of-band packages, so things like the way, system collections immutable. That's an out-of-band package. They're going to do more like that and try and work like that, especially if the assembly itself is purely IL, it's got no runtime concerns, and also if it's based on the .NET Standard already, it makes sense just to ship it as an out-of-band package. For things that do make it in, there's going to be a set of criteria which have to be met before it gets in. Firstly, it has to be a ubiquitous API. It has to be used everywhere. If it's going to be in the standard, which goes everywhere, the API has to be useful everywhere as well. So it's no good putting something which is a Windows display framework kind of thing if it's not going to run on Windows. The API needs to be mature as well, because it's going to be in the API forever. It's going to be in the standard forever. So they want something which is stable, mature, and is doing the job it's supposed to be doing. And finally, the other one is things with runtime considerations, where the runtime needs to get involved. Not necessarily the platform, not talking about platform-specific things, but runtime, like CLR stuff. And SIMD support is a good example of this. This is where the JIT, they would need to recognize certain types and compile the machine code to take advantage of processors to do vector maths in a more efficient manner. That's a good example of something which would fit in the standard, because then the runtime has to implement that differently. Does that answer the question, by the way, about how to deal with that? Good. Right, let's have a look at packaging then. OK, so I've already said that it comes in a NuGet package. This is the netstandard.library package. There's kind of 3 different versions. Let's have a quick look. Where are we? This one, I think. I'm in the wrong place. So has everyone seen NuGet Package Manager, by the way? Package Explorer? It's a really useful little tool for... No, I don't want an update. It's a really useful tool for examining your examining packages. You can search for them, download them, and show us what's inside them and stuff. So net standard library is the package which defines the .NET standard, and there's a couple of versions, a couple of preview versions, but really we've got 1.60 and 1.61. So we haven't got any of the previous versions there. And this is what I'm trying to say, the version of the package is not as important as what's inside the package. So if we load that up, first thing you'll notice on the right-hand side, there's no lib folder, or anything. There's no DLLs in this package. It's a meta package. And by meta package, I mean that it now has a whole bunch of dependencies on other packages, and those get pulled in. And that's what defines the standard. And so on the left here, we have dependencies on the .NET standard. This is for the target framework of .NET standard version 1.0, all of these packages get pulled in. And we can sort of follow that there, and we can see what DLLs and assemblies were referenced there. We've got a similar set for 1.1, another set for 1.2, a set for 1.3. And so if your project targets these particular versions, then that particular set of references will be included. But what's interesting is that despite the fact we're up to 1.6 and running onto a 2.0, is we've only got a target framework there for 1.0 to all the way to 1.3. There's nothing for 1.4, 1.5, 1.6. And that's because the package dependencies define what other packages get pulled in, and 1.4, 1.5, and 1.6 didn't add any new assemblies. And so there's no change to the number of assemblies that get referenced. What has changed is the actual packages that are being used. Let's have a look at system runtime. And so if we pull this one in, we get to see that there is a lib folder and a ref folder. So the lib folder kind of has some DLLs in there for us, and the ref folder also has it as well. And we can see here now we've got different versions for 1.0, 1.2 to 1.5. Not everything, because not everything, it didn't change in all of those versions, and so normal fallback rules take account there. Okay, so yeah, that kind of covers everything we've got there. The new, I don't think, did I show you the framework monikers? Yeah, so yeah, I didn't point out really that those are the new framework monikers. They're net standard, and it's 1.0, 1.2, and everything. Interestingly, it moves away from the net 45, and it puts a decimal point in there. I'm not sure why. But there we go. Yeah, and the target framework decides what you do, and also fine-grained package versions. Right then, .NET Standard 2.0. So this is the fun stuff. This is the new stuff, the interesting stuff, and all the changes that are going on. First thing to say is it's a work in progress. It's not finished yet. It's going to be shipping with Visual Studio 2017. And the big thing that it does is it gives us loads more APIs. As you see on the, well, we can see right there, all of those APIs now are being added back in. So that's lots. Definitely why I class loads more. It also consolidates sort of reference assemblies as well. So whereas that package we just saw had a load of dependencies on other packages and other DLLs, it's now going to change. We're going to have one DLL, net standard DLL. The idea of this is that the standard itself is monolithic. So why is it split up into lots of different assemblies? Just have one assembly that describes everything. Similarly, we're going to get rid of those package dependencies. But the important thing to say is that it's got the same goals. Nothing is changing with there, despite big upheavals and changes in how it works and everything. It's still intended to do the same thing. It's still intended to share code across everywhere. And in fact, it's possibly more so, because this is one of the quotes on the docs for version 2.0. It's saying 100% source and binary compatibility for classic .NET Framework and Xamarin assemblies, and also existing portable class libraries. The important thing to point out here is 100% source and binary compatibility doesn't mean that all APIs are going to be available. It means it's going to have 100% source and binary compatibility across platforms. So this means you're going to be able to use it on all the platforms, and they will always be available. So kind of what was wrong with the version 1 series? Why do we need such a big upheaval and a change to 2.0? And the simple answer is there were just not enough libraries targeting the .NET Standard, or portable class libraries. So the majority of NuGet packages are .NET Framework packages. And that means that with a new platform like .NET Core, it's very hard to consume those because it's just too different. So the stats that were released was when they sort of announced the .NET Standard was that there are about 45,000 NuGet packages targeting the .NET Framework, versus 4,500 targeting portable class libraries versus 1,800 which implemented the .NET Standard. So there's a huge amount of code there which platforms like .NET Core and other new platforms that come along, sort of other mono builds, other Xamarin and Unity platforms won't be able to take advantage of that code. The other issue is that it's tightly coupled to the .NET Core. So the .NET Standard was built from the .NET Core because it was a requirement for the .NET Core. But that means that right now with the 1.0 series, 1 series, you can't evolve the .NET Core separately. If you add an API into .NET Core, it'll kind of get into to the standard. And secondly, just not enough APIs. So .NET Core refactored a whole bunch of APIs. It refactored the libraries, and it moved things around. It changed the shape of certain APIs. So we're not just removing things, but changed the shape of them as well. So reflection changed, and other things got removed. And I like the quote here. They said they kind of cleaned this up there, but the cleanup went a little bit overboard. And they did change things really quite drastically. And all that kind of means that porting applications to .NET Core was harder than it needed to be. And it was kind of tricky. And so they're going to add in all these APIs back again. And instead of adding absolutely everything from the .NET Framework, they're going to be pulling in an intersection of the .NET Framework and Mono and Xamarin stuff. The rationale behind this is that the idea for .NET Standard is to work across platforms, and Mono and Xamarin have already been very successful at working cross-platform. And so if the APIs are in Mono and Xamarin, then they are probably the APIs that we want to use. And so it's going to be an intersection of what the .NET Framework has, what Mono has, and work from it from there. Platform-specific APIs are going to be excluded for the most part. So it doesn't make sense for the .NET Framework to pull in WPF or Windows Forms, because obviously that's not going to work on all platforms. And so for the most part, platform-specific stuff is excluded. But some APIs are going to be pulled in, and they are going to be used. And some of them are going to work in different ways. So sometimes they're going to be emulated. And so things like the registry, for example. Yeah, yep, faces being pulled in the audience there. We don't necessarily want the whole of the registry there, but sometimes it's really useful for saving application settings. And there will be existing code out there which is doing that for application settings. And so if you emulate it, Mono already emulates it with ini files, for example, then that can be very useful for an application point of view. But then if you want to use it for something to look at system settings, then at runtime, it'll probably fail. Similarly, things like app domains. So various platforms like .NET Core don't support creating app domains. But the APIs are still going to be there because various other things do and require it. But at runtime, they will throw exceptions. So what's going to be in the .NET Standard 2.0? All of these things. Basically, it's a high-level overview of the files, of the APIs that are going to be in there. It's not just this isn't just the changes. This is kind of everything. So, for example, threads, thread pool, tasks, and everything. A lot of that was already in .NET Core and already in the .NET Standard. But it adds back things like the binary formatter for serialization, and so you've got compatibility with previous code there, XPath and Xlink as well, and code like that. And again, if you go back to the GitHub page for the docs there, you can kill your browser and look at all of the APIs. Right, so another somewhat controversial change they're doing is changing the way the APIs are referenced, the API set is defined, by putting everything into one library. So if we have another look at, I've closed that one already. So if we have another look at our net standard library, our 1.0 series, then we see we've got a lot of different assemblies being pulled in. We're pulling in lots of different packages, and there's a lot of APIs going on there, a lot of assemblies going on. Not right now. So That's going to change now, and the API is going to be defined by net standard DLL, by a single API, a single assembly. Because the specification is monolithic, you have to have everything. You can't mix and match. You have the whole API set there. So why have reference assemblies as fine-grained and small? Just have them as a single one. But this has implications then on packaging, on implementation, and also on backwards compatibility. The existing assemblies which reference the .NET standard are expecting to have all these fine-grained assemblies around, and now they're going to be they'll have gone. It's also going to split with the .NET Core, as I say, previously built from the .NET Core source code, now has its own repository on GitHub in the .NET/standard. You can see all the APIs defined there. They're all defined as C# files, and it builds it and compiles, and you can raise issues against it. You can talk to the project maintainers there. And by splitting it out now, it means that .NET Core simply implements the standard. It's no longer a special case, whereas before it was driving the standard. The other thing is that .NET Core is also deprecating the fine-grained packages that it had. Because .NET Core needs to implement the whole standard as well, then it also makes no sense to have all of the libraries as separate libraries. But this was also one of the selling points of .NET Core, was that you could have a pay-for-play. You could deploy just the assemblies that we were using. And so this is now going to have implications on deployment, was that if you've got a single platform package which includes everything, then it's much more of a heavyweight platform. And there's talk of tooling to help this as well. So post-build, you can do trimming, and it'll just include just the dependencies you have, and you can deploy that. But right now, it's just going to be the whole platform. What would be interesting would be to know who was already deploying .NET Core applications as standalone applications, trimmed down, and who was deploying it as a platform application as well. And so whether it's going to cause much of a trouble. All right, does anybody have any questions where we are so far? Right, very good. Right, so I want to have a look at how it works and how we can sort of fix everything up and make everything work so that the differences between platforms work okay, and the differences between versions also work. So there's two ways that this works. Firstly, reference assemblies, and secondly, type forwarding. Reference assemblies are dead easy. They're just the assemblies that you pass into the compiler, and that defines the APIs. If you try and use an API that isn't in that assembly, you'll get a compiler error. So that's how we define our API set. It's a reference assembly. The compiler's not interested in the implementation of any assembly you reference. And so reference assemblies themselves, they use empty types. So they have methods which have no implementation, they don't return anything, and they're just void methods. So if we have a look at a really big file. Not entirely sure why that's gone so big, but we'll do that. So that's not a good example. Let's have a look at, where are my classes? So here's an example. This is one of our reference assemblies here, and you can see that all of the methods then are just empty. If we have a look at another one there, there's nothing going on. Things are just, they're throwing, they're not even throwing a proper exception. They are empty types, because the compiler is just not interested in the implementation. So the implementation assemblies then, which do provide the implementation, these get resolved at runtime. These are implemented on your system, they're installed as your system, and these contain the actual implementation. They must contain at least the reference types and members that you've got in your code, but they can obviously contain more APIs. And so they can have, just because you're not referencing something doesn't mean it's not allowed to be in there. And this is how a platform can support the supersets of versions, and it can support a later version. If you have a look on your system, you've got the Microsoft.NET folder for .NET Framework. These are all your implementation assemblies. If you had a look at those in the decompiler, you'd see the actual code and what it's all doing. If you fired up the compiler and you used those as a reference, you wouldn't be targeting a particular version of the framework. You're targeting the version of the framework you have installed. And so you wouldn't be able to manage the APIs that are available to you. And so Visual Studio and MS Build, they use references assemblies, and they've been doing it for absolutely ages, and they use that to target the particular framework you're on. So you've got the drop-down inside Visual Studio. That's telling Visual Studio and MS Build to use that particular folder. So we can have a look at that if we pop back to here. And so we've got program files, reference assemblies, and a .NET framework. In fact, if we go back here, there's a whole bunch of them, from version 3.5 through to version 4.6.2. And if you have a look in here, there's a whole load of assemblies that are going on there. And I could drag one into, where are we? Nope, there. So let's drag one in. And again, if we looked at a type in here, something that isn't an exception, then again, that's got implementation. Typical, the one I pick at random isn't a reference assembly at all, it's got an implementation. But you can pretend that's empty, and that would have been a whole lot better. Don't pick things at random in future. Excuse me. Oh yeah, I wanted to stay in Windows there a sec. Because Visual Studio uses reference assemblies from that folder, whereas if we go back to NuGet, and we have a look at one of our assemblies here, System Collections, for example, and we open that, what we can see is we've got our lib folder, as you'd expect, with implementation DLLs in there. We've also got a ref folder. So NuGet actually knows how to ship reference assemblies as well. It's got a ref folder and particular target frameworks as well, and then the DLL there, and that DLL will be an empty reference assembly as well. All right, so when you do make a reference on something and you embed a reference into a type on there, the compiler actually embeds that reference as an assembly qualified name. So it's not just the namespace, system threading timer, it also embeds in the assembly name in there as well, system.threading. It also embeds the version and any public key information as well. And the runtime uses this when it's resolving all the types. It looks for system threading DLL and makes sure it's loaded, and it uses that. One of the things that is important with the CLR is that when you're comparing types, the assembly name is taken into consideration. So if I had system threading DLL, which contains system threading timer, that is a different type to system.foo DLL, system threading timer. And so they're not equivalent. And this then causes us problems with platform implementation differences. So this is a good example down here. System.object. On the .NET framework, that's implemented in MS Core lib. But in portable class libraries and in .NET Core, that's implemented in system.runtime. We need to try and unify that, because just as it stands right now, those types are not the same. And so if you've got system.objects, which isn't the same, then that's going to cause you massive problems. So this gets fixed by type forwarding. Has anyone come across type forwarding at all before? Yeah, type forwarding is a nice mechanism within the CLR, which is an assembly level attribute which simply redirects the type to another assembly. So we've got this type forwarded to, we give it another type name, and it is then, when the CLR tries to load that particular type, it sees the attribute, says, oh, okay, I need to look in another assembly, and it goes and resolves it from there. One thing that type forwarding can do is it can't rename anything. Everything has to be in the same namespace. It can just move things into a different assembly. It redirects at runtime, but also it redirects at compile time. So it can fix up references at compile time as well. So the compiler will also follow these attributes. So what it allows us to do, it allows us to reference a type in one assembly, but implement it in another. This is useful for platform differences. It's useful, such as system.object being implemented in different assemblies, but also for refactoring the platform, for how .NET Core, for example, could split things out into different assemblies. How does this affect the .NET standard? Well, the API is defined in these reference assemblies which are included in the package. And the version 1 series libraries, they reference types in system.something.dll. So the whole bunch of system.thingy.dll. And then when that gets resolved at runtime, each platform can then put in type forwarding to actually put it to the real implementation. So we can have different implementations on different platforms. So we get to the more interesting question, what can reference what? So this is now more about the compatibility. How do things, what is it that you can reference between things? If we look at the .NET Standard 1, you get this kind of pattern here. So across the top now, we've got our application frameworks. So we've got .NET Framework, .NET Core, Xamarin. Xamarin is very similar to .NET Framework, as it happens. They can then reference a .NET standard library built with the .NET Standard 1, so .NET Standard Assembly. And then the .NET Standard Assembly itself can reference another .NET Standard library or a portable class library. Now we'll quickly walk through how this works, because there is differences with the type systems here. So when you are compiling your library, your .NET Standard 1 assembly, the references there, they are all talking to system.thing.dll. When you're referencing a third-party .NET Standard library, they're also referencing system.thing.dll. So no compile errors. That's all good. That just works. Portable class library also references system.whatever.dll, and so no compile errors, and that works. Portable class libraries possibly have more APIs than the .NET Standard 1, and so there's also another package you can use there. You can bring in Microsoft NetCore portable compatibility to add in those extra APIs. When you're then building your app at the top level, firstly, you need to sort of add a reference to your new assembly. And there are changes to NuGet to make that work. So NuGet understands the mapping between the platforms and the .NET Standard library. So it knows that .NET 4.6, if you are targeting .NET 4.6, you can include anything which targets .NET Standard 1.3 and below. When you're compiling .NET Core, everything references system.whatever.dll, and so no compile errors. So everything's great with that. So we've now got us like a full stack of everything being referenced. But .NET Framework and Xamarin, they don't have system.whatever.dll. They have things living in MS Corelib. And so we need to fix that up. And the system actually gives forwarding reference assemblies which fix up those changes. So if we go back and have a look at, where are we? There. In our references assemblies folder up here for 4.6.2, if we go up to the top, there is a facades folder. And this now gives us the API set from .NET Core, from .NET Standard 1. Whatever. And these are just type forwarding assemblies, and these will forward straight to MS Corelib. And so that fixes things up and means that we've got no compile errors. And we can then reference from .NET Framework to .NET Standard to a third-party .NET Standard or a portable class library. At runtime, we're still going to have references to system.whatever.dll. That's fine for .NET Core, because everything just matches one-to-one. Again, for the desktop frameworks, those runtime facades are in place, and they're also installed into the Microsoft.NET folder, and that just redirects everything as well. .NET Standard 2.0 has the same sort of idea. It allows you to reference .NET Standard library and portable class libraries, but it's also adding in support for .NET Framework libraries as well. And we'll kind of quickly walk through that too. The change to .NET Standard DLL changes a bunch of things as well. It makes things a bit trickier. So when you build your library in the middle there, all of your types are referenced as being part of .NET Standard DLL. When you reference another .NET Standard library assembly, if it's .NET Standard 2, everything's fine, because it's all .NET Standard DLL. Everything just works, so no compile errors. But if you're looking at a 1.0 series library there, everything's referenced as system DLL. And that won't work. That would give you compile errors. And so what happens is the .NET Standard library includes a whole bunch of system facades there, which then type forward to .NET Standard. So we've got things pointing again to move things around and do that. And at compile time, it'll fix up those references and fix up your compile errors. The same is true for portable class libraries. They're expecting system.whatever, and so they get pulled through and redirected. Your additional package is no longer necessary now because the new APIs have been added. And then we get to .NET Framework, which is all different again, because now we've got the references in there of talking to MS Corelib rather than system.whatever.dll. And here again, we see that the .NET Standard library, so I've got the package for the .NET Standard Library 2. As you can see, it's still work in progress because it's 1.7. But that includes .NET Standard DLL here, which has got our whole API set in there. And then it's got a whole bunch of system DLLs to type forward. It's also got MS Corelib as well. And in fact, if we have a look at that, I've got the NuGet package open here. If we have a look in net standard, we see there's a whole load of namespaces and a whole bunch of types in there. But then if we go to, say, system.console, we see there are no types going on in there, but there are a bunch of type-forward attributes. So the NuGet package will automatically forward away for us for that. It also provides MS-corelib, which doesn't have any implementation. And if we open that, we then get even more type forwards as well. So if anything is referencing MS-corelib, we've got the type forwards here, which will point to net standard. So it's going to point everything to net standard for us and unify all those types. So when you're compiling your application, again, the .NET Core ships with a net standard DLL, so everything works and everything's fine. So that's good. That's going to be .NET Core 2.0. But we could have a transient reference to MS-corelib, and so that could cause us problems. So what happens here is we've got a package. The .NET Core app package includes the net standard library package, which includes the MS-corelib facade, which forwards everything to net standard, which gets forward to the real implementation. So it's chaining everything along, and it gets repointed to the right thing. And then also, we kind of have to do the reverse then for the desktop frameworks. So then we have the desktop frameworks which have a reference to MS-corelib. Sorry, it's got references to net standard, and they need to be forwarded to MS-corelib. This isn't yet implemented, so we don't have this yet, but there will be a forwarder in place for that. There's also going to be transient references here. So the portable class library will have references to system.whatever, and the .NET framework, the .NET framework one there has references to MS-corelib. Those are already implemented by the system, so everything's fine there, and it just works. And at runtime, the net standard DLL is forwarded simply to the actual implementation for .NET Core. And on the desktop, again, we need a forwarder from net standard DLL to MS-corelib, and that's still part of the work which is in progress. So that boils down to .NET Standard 1 can reference a .NET Standard 1 assembly or a portable class library. .NET Standard 2 can reference a .NET Standard assembly version 1 or version 2. It can also reference portable class libraries, and it, more importantly, can reference .NET Framework assemblies as well. So that means we can make use of all the .NET Framework assemblies and packages that are available on NuGet for us. The other important thing is that NuGet knows the mapping between these things. It knows the mapping between the platforms and the .NET Standard versions. So when you are implementing a platform and you're working with it and you want to consume something, NuGet knows which version you can consume. And it also allows then the referencing between the .NET Framework libraries and from .NET Standard platforms. OK, so that kind of brings it to the end. That kind of covers everything, really. And so to recap, the .NET Standard, it's a specification which lists all the available APIs across the platforms. It's a replacement for portable class libraries. It changes the model. It makes it so that portable class libraries are more extensible, and you can add new platforms in there. And the other big thing, really, is that 2.0 is adding back all these APIs. So it's going to make porting your code a whole lot easier, because you should just be able to consume both, .NET Standard platforms will be able to consume .NET Framework assemblies, and vice versa. .NET Framework stuff will be able to consume .NET Standard stuff. So a couple of useful links, just to finish off then. The .NET Standard is actually on GitHub, as I said, under the .NET repo, .NET/standards. There's some really useful documentation in there. That's where the links to the version information is on. And also, Imo Landworth from he's a program manager on the .NET team. He's got a number of very, very useful videos which explains this stuff as well, and they're well worth a watch. And then if you want to have a play with it yourself, even though it's still in progress, it's still currently called .NET Standard 1.7. You can get it off NuGet in the .NET Core repo there. It's called Net Standard Library 2, although that will probably be unified as progress goes on. So that's kind of me finished. I don't know if anybody has any questions right now. Hello, yes? Oh, we've got a microphone, sorry, so we can record it.
I have a question about referencing portable class libraries, if it gets any easier. Before .NET Standard, one of the problems that could be that if let's say I have a library that I want to reference two other libraries, but they are incompatible profiles.
Yep.
That's the problem. Can I then repackage my library to use .NET Standard? Will it be possible then to reference these two other portable class libraries, even though they have incompatible profiles?
Possibly not because of the incompatible profiles. So there are, if we go back to the links for .NET standards, where is it? There is a mapping of the profiles which are available down here. So you can't consume all portable class libraries, but there's a subset of them which you can consume. And these profiles here are what you can consume and what version of the .NET standard it maps to. So as long as those map to a version of the .NET standard, you should be able to take them, yes. But if it's incompatible right now, then the likelihood is that they won't map to something there, and in which case it won't be able to do it. However, if it's your library, you could repackage it to be a .NET standard library, in which case then you can work around whatever API differences there were, and then you could consume it from different places again.
Mm-hmm. Thank you.
Okay, cool, thanks. Any other questions? No? Okay, I think we're done then. Oh, no, we have one question over there, sorry.
Hi. So the early promise of .NET Core, particularly for web apps, that you can put everything in the bin folder and not care about the rest of the machine and only ship the parts you want. So how's that going to play with this big monolithic DLL? Has anyone come across that yet and found that their deploy is 10 times the size, or?
I think it's too early to say about that. So it is changing the deployment model. So right now everything is going to have .NET Core is going to have a platform package which includes everything, which means that you can't do this smaller model and smaller deployment. But there's talk of tools which will then, after you've done your build, trim everything down so you've got a smaller deployment model. But right now everything is still going to be this big thing. But also, because when it's not done, it's hard to say what the size is of all of that as well. So it might be that it's still a reasonable size rather than millions of gigs.
Right, but those tools are going to be very non-trivial, because as soon as you do some reflection or IOC, you could be loading stuff which is very hard to work out by inspecting the code what's being referenced.
Yep. Mono already has some tooling in place for similar kinds of thing, which does that kind of thing. But yes, reflection can cause you problems, and you have to then provide extra inputs to say, I also want these assemblies as well. And maybe it'll just be that it'll work with the .NET standard libraries themselves, so it can trim down the platform, but it won't trim down any of your code or your third-party references. It's not yet defined. But of course, the current position now with a monolithic package is the same as when you do an SDK-based platform install. So where you install .NET onto the whatever it is, the container that you're running in, and then you just install just your application, and the dependencies are there as part of the platform. Okay. Right. Well, thank you very much for coming then. And that's good.